able to contain its cost per tonne railed because of its application of that advancing technology.
Another important point is to understand that the people working within the railroad, the drivers, the track maintenance people, rolling stock maintenance people, and even the administrative staff, all of us are working together to make this integrated operation successful.
This scene takes place 6 times every day as the locomotives come in, now mostly 5 at a time, for service and turnaround at the headland workshops. The crews swarm over each loco to make sure all systems are fully operational for the tough 16-hour journey to the mine and back. Major repairs are carried out in the locomotive overhaul workshop. Mount Newman Mining's 53 United States-designed diesel-electric locomotives have served the company well. It began with 5 in 1968, 2 more came online with the opening of the railroad in 1969, and 11 were added each 2 years thereafter, until a fleet of 49 were in service. 4 more were purchased in 1977 to total 53, and since then, 1 has been retired. Mount Newman has completed a rebuilding program for 8 of its locomotives, which were trucked the 1,500 kilometres to the Perth workshops of private contractor Goninen and Company Limited. At a cost of more than $2 million per unit, about 2/3 the cost of a new locomotive, each loco was stripped back to its underframe and original bogies. The original Alco engines have been replaced with General Electric power units, which have bigger radiators and beefed-up cooling systems to cope with the scorching temperatures of the intake during the high summer months. And there's a cooler ride for the crew in the rebuilt models. A special committee of drivers, management and construction contractors designed a completely new cab to bring more efficiency and comfort in the long journey down the track. The new cabs have a clean design with no protrudences to hamper or injure the crewmen as they move about. The cabs have more soundproofing and air conditioning to cope with the rigours of the north. 4 new GE-8 locomotives were under construction at Goninen through 1988, with the last of them for delivery at the end of that year.
This loco's a rebuilt loco, and it's got the, as you can see, it's got the bigger cab. And we've got a lot more room to move, a lot better visibility, and it's got a little bit more power too, which that's why we've got a good speed up the hill here. We were doing 30 odd kmh, we're down to 24 now, but we're just about to the top, so a lot more efficient. There's no mucking around, very easy running. You just jump on your train and you go from point A to point B, and very rarely do you have any problems.
The rebuilt and new locos are the most modern used in the world's iron ore companies. Each has a power unit of 2,680 kilowatts and a fuel capacity of 18,000 litres. Each round trip of 852 kilometres takes 5,750 litres of diesel per locomotive. Along with the locos, there's a new generation of rolling stock ahead for the Mount Newman line. The company has 2,071 ore cars and 114 other units of rolling stock. These are constantly being repaired and refurbished in the headland workshops. Inevitably, they're wearing out, and maintenance can go only so far. The first of them cost $25,000 each. Those purchased in the 1980s cost about $40,000 per unit. The new ones ahead will cost more than 3 times that much. Current units are of the 1950s and 60s design, with a tare weight of 25 tonnes for a payload of 100 tonnes. The target is to better the present tare weight to payload ratio of 4 to 1 with a reduction in car weight and aerodynamic streamlining. The search has taken the management of the Mount Newman mining ore car repair shop to many countries in quest of the most suitable new units. Lighter cars with, say, a 3 to 5 tonne reduction in the present 25 tonne car weight will bring a big saving in haulage fuel costs. The present cars are made of steel. The new ones will be of stainless steel. Present cars have a 32.5 tonne axle load. The aim is for a 40 tonne axle load, with lighter castings and independent suspension. The new cars will have a drop belly design to give greater volume. Also, there will be new wheel shapes with new alloys to overcome such problems as shelling, the defect that develops in the subsurface of wheels exposed to heavy loads. Ultrasonic testing has been introduced for the checking of wheel soundness, this replacing the now labour-intensive hand check method. Big changes are taking place along the permanent way. Each of those changes interacting with one or more of the others to bring a smoother flow to the company's overall operations. For example, new marshalling yards at both Newman and Port Hedland are allowing a smoother turnaround for rail traffic to the port. At the mine, a new yard and access road bridge are allowing a smoother flow at that end. And in between, there are many new developments and innovations taking place, some of them of world interest. A special head-hardened rail is a Mount Newman mining maintenance idea developed through the Melbourne Research Laboratories of the parent company BHP. Engineers have come from all over the world to see it.
The existing rails of standard carbon steel are being progressively replaced with head-hardened rail, which dramatically increases the life of both rails and wheels. The present life of standard carbon rail is 770 million gross tonnes. Already head-hardened rail sections have been in service for 270 million gross tonnes, and engineers expect that lifetime to go to 2,000 million tonnes.
Nobody knows what the upper limit will be, but it certainly means massive savings for this railroad and of course for all of the other railroads that follow. The special profiling of the head-hardened rail and the ore car wheels gives a minimal contact band to reduce friction and therefore provide a longer life for rails and wheels. Fundamentally, the method is to run the wheels on the centre of the rails. This results in no flange contact. The computer design of the railhead profile, together with the special wheel shape, allows the cars to be steered through the curves rather than by the flange of the wheel. Even though the Mount Newman mining track has one of the heaviest throughput tonnages in the world, it's perfect for the use of the new methods. It's a continuous track, with its dual ribbons of steel running in unbroken strips through their entire length, rather than the mixed tracks of other railroad systems. Further, all the variables can be controlled because of the fixed design of all the rolling stock, as against the mixed bag of wagons used in multi-purpose railroads. Another area of saving has come through the use of swing-nosed frogs at rail intersections, which reduces the gap bounce and consequently the need to replace units so often. This track unit is another interrelated efficiency step in the operations of the Mount Newman Permanent Way. It's a continuous action tamper, which maintains track geometry to reduce wheel and rail wear. Working at 3 times the normal rate, the tamper lifts 2 sleepers at a time in its continuous run while pulling the line into position. It was the first unit of its kind in Australia and can cover up to 1.5 kilometres of track every hour. The Newman track's ballast cleaning process is among the best in the world. Dirt borne by wind and water over the 2-decade lifetime of the railroad has tended to break down the strength of the ballast. As the cleaning process proceeds, higher strength ballast brought in from the company's Chichester